This is how a P wave or compression wave looks in a slinky. The compressed section moves along the slinky. After the compression passes through a section of slinky, that section of the slinky goes back to the way it was. P waves do the same thing inside the planet, except it's rock that compresses and expands. The molecules in the rock tug on each other, rebounding everything back to their original places. P waves can go through both rocks and liquids. The other kind of seismic wave is an S wave or shear wave. Here, the rock vibrates in one direction while the wave moves in the other direction, just like flicking a rope. S waves cannot go through liquids because the liquid molecules don't tug enough on each other to make the atoms return to their original places. S waves can only go through rocks. If the S waves are too powerful, they tear the rock apart. It's one of the more devastating effects of earthquakes. Let's race some waves to see how they're affected by different materials. And they're off. Rocky and Maggie are neck and neck coming out of the gate. Uh-oh. Looks like Maggie has really slowed down. Unfortunately for her, waves move faster in stiffer materials. Rocky really has an advantage in this race because the solid rock is very, very stiff. The winner is Rocky in a landslide. In addition to changing speed, the wave's direction can change too. This happens when the material that the wave is traveling through changes, like from rock to liquid. At the boundary, part of the wave reflects back. The part of the wave that passes through changes direction or refracts. All of these things happen in earthquakes. Compression waves or P waves travel through the rock and the magma, reflecting and refracting as they go. Shear waves or S waves travel through rock but not liquid.